Good morning, good afternoon, and good evening. The authors and distinguished guests, welcome to Technical Session 1B. I'm Sanskriti and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, that is ICTIS 2026, being hosted in Bangkok, Thailand. This 11th edition is being conducted in a hybrid mode. The physical conference will take place tomorrow in Bangkok, while the virtual sessions are being conducted via Zoom from 9 to 11th April 2026. I hope you find today's session insightful, engaging, and intellectually enriching. In this session, we have 10 presentations. Each presenter will have 10 minutes for the presentation, followed by 2 minutes for question and answers. A gentle reminder will be given at the 9 minutes mark. All participants are requested to remain connected until the closing remarks. For any queries or updates, please use the chat box. Before we begin, I would like to introduce the session chairs for this session. Dr. Preeti Prakash Zarwekar is a principal senior analyst at Calsoft Private Limited in Pune, India. Her research focus includes predictive modeling, deep learning architectures for smart agriculture, and data mining algorithms. She's actively involved in industry research, technology analysis, and developing innovative solutions in evolving IT domains. Welcome, ma'am. Would you please like to share a few words with us?
Hello, everyone. Thank you so much for providing this opportunity to have a session chair here. And I am really thankful and eager to listen the presentations. Thank you so much. And all the best for all the presentations. Am I audible, all of you?
Yes, ma'am, you're audible.
Yeah.
This session is co-chaired by Dr. Raina Bhavin Kumar Thakkar, who is a Deputy Program Director at the Canterbury Institute of Management, Australia, with over a decade of experience in academia and higher education leadership. Her expertise lies in business information systems, data modeling, and the integration of information technology in business environments. Welcome, ma'am. Would you please like to share a few words with us?
Thank you for the introduction. Good morning, everyone. Thank you for having me to chair this technical session. Looking forward to view some diverse and edge-cutting presentations on the recent topics. Thank you.
Thank you, ma'am. Now I will begin with the presentations. First, we have Rahul Basu presenting his paper on 3D fractal characterization and phase field simulation of spinodal decomposition in binary alloys, a computational study for intelligent material systems. Mr. Basu, you may please start your presentation.
Good morning. Can you hear me?
Yes, you're audible.
Shall I start? Can you see my screen?
Yes, your screen is visible.
Okay. So, the title of my talk is about 3D fractal characterization and phase field simulations of binaural decomposition binary alloys. So what I do in this paper is we look at the 3D computational framework to model the Carl-Hilliard phase field model with fractal dimensional analysis of the evolving microstructures in certain alloys like copper, nickel, and iron chromium. The fractal dimensions are given below during questioning 2.4 to 2.8, which is less than 5% mean square error. Then I use a FFT solver and then look at the time evolution of domain coarsening, which has an exponent that varies with time. Now, in this slide, you can see the governing equations of this famous Carnelian model, which is compared to the usual diffusion equation, it has some extra terms. Diffusion equation is a second order parabolic. The Carnelian equation has an extra fourth order term, which is due to the derivative of the free energy. And this equation is theoretically very difficult to solve. So the approach is to do it by numerical methods. And the equations are illustrated over here. This is a free energy, which has, you have to minimize this with double well. And the composition evolves by this parabolic equation. So the methodology for simulation is to first initialize with certain initial conditions, solve, and then analyze the results. So we have simulations for copper nickel and iron chromium use 128 by 128 grids and then we can, if time and resources allow, you can go up to 256 because you get more accurate results with the 256 grid, but it takes much longer. And convergence is set by the program with less than 1%. The results are shown in this slide. I summarize the most important in this graph here. This graph shows the domain size versus time. And we see that it approaches an asymptotic state. And the slope should approach a 1/3 law. However, due to the small box counting sizes, we are limited by time and the computational constraints. We can get this theoretical slope of 1/3 by using fast Fourier transform. Right now, I show it is a rapid decrease and then goes to asymptotic. So this slide will show you how the microstructure evolves. In the early stage, we have a fine scale compositional modulation growing continuously within unstable regions. And then as a late stage occurs, you have self-similarity. Here you see the pattern remains the same. Here it starts with unstable and then increases to replicating patterns, which is characteristic of a spin order. Smoother interfaces and isolated regions characterized by ripening, Ostwald ripening. And the dimensions are given here 2.5 to 2.7 for iron chromium and mean square error of 0.04. Another slide here will show you the simulation as time progresses. These are 3D isometric views. So on 64 by 64 grids, the exponent goes to 0, which is due to saturation, which is denoted by Bray. And this is a well-known computational failure. Large grids restore the classic LS diffusion control cosmic. If you use 256 by 256 by 256 simulations, you get 0.32, which is approaching the theoretical limit of 0.3. Now, what are the physical implications? Due to elastic strain, the Allen-Kahn coupling reduces the diffusion coefficient due to anisotropic domain morphology. Composition-dependent mobility is shown by this binary expression. So the mobility varies as the concentration squared. Irradiation and effects, dislocations and elastic heterogeneities modify kinetics and spatial morphology. Irradiation offers spinodal kinetics in uranium molybdenum alloys. And then the extension is to high entropy alloys, multi-component systems, such as in aluminum-rich high-energy, high-entropy alloys. Another key tool is the use of structure factor to analyze the structure which evolves. Here we see a typical peak which shows the interparticle distance here, interparticle distance, and the shape of the peak will show the morphology. If the shape remains the same, then we know that morphology remains more or less constant. The only change as time goes on, this peak will shift, showing the interparticle distance changing. It is derived by the structure factor of the Fourier transform. Structure factor is obtained from the Fourier transform. The dominant peak corresponds to the fastest growing wavelength, predicted by the linear stability analysis of the Cornelian equation. Now, to summarize this, the fractal dimension of 2.4 to 2.8 during the early stages, and the 256 grid recovers the Lipschitz size of exponent of 1/3. And the informatics depend on the fractal metrics, which are descriptors for the data-driven alloy design. FFT efficient approach enables performance forecast. Future work involve the different databases, dislocation dynamics, and the real-time fractal charts, and extensions to high entropy alloys and irradiation. Thank you very much. Any questions, I can be contacted on my email. And appreciate the chance to give this talk. And here are some recent publications of mine on these related topics. Thank you. So any questions, please feel free to ask.
Hello.
Hello.
Yes, I have one question.
Yeah.
So, how this research contribution will going to help in real-time fractal tracking? Can you
Yeah.
elaborate?
So the one of the applications is in the superconducting materials. This is due to a phenomenon known as flux spinning. These interparticle structures, which is characteristic of spinodal structure, they trap these magnetic vortices. So the trapping allows the currents to pass through much quicker. Because otherwise, if the magnetic fields interact with the electric fields, uh, you have resistance and heating, which changes the low temperature of the alloys. This is one of the problems they face in superconducting air, making material superconducting, which helps in this phenomenon called flux cooling. Has that answered your questions?
Yeah, sounds good. And what are the different application areas where we can use this application or algorithm?
Yeah, this spinodal alloys have extremely good mechanical properties also, because they don't allow, apart from magnetic fields, they don't allow cracks to propagate. They get trapped the same way a magnetic field gets trapped and forms loops around these vortices. So dislocations and cracks are impeded by these particles. They're like what you have in particle reinforced composites, for instance. So they have very good mechanical properties and creep resistance.
Okay, I'm good. Thank you.
Thank you very much.
Any other questions?
No, I think the questions has been asked. Okay.
Thank you, Mr. Rahul, for your presentation. Next, we have Mr. Srinivasa Reddy presenting AI-driven parallel growth stage identification and yield estimation using deep combination neural networks.
Yeah, thank you, madam. Good morning. Yeah, let me share my presentation.
Mr. Srinivasa, you may please share your screen.
Yeah. So yeah, is it visible? No?
Yes, this was him.
Let me maximize. Yeah. Yeah. So first of all, thank you for giving this opportunity to present my work in your esteemed conference. Yeah, very good morning to the respected panel members. Today I am presenting. Wait. Yeah. So is my screen visible with the PPT with the full maximization?
Yes, this
Yes.
was him.
Yeah, thank you. Yeah, so my topic is AI-driven paddy growth stage identification and yield estimation using machine learning and deep learning. We are from Lakredi Baladi College of Engineering, India. So this is my presentation outline. So coming to my main problem statement here. So currently farmers monitor paddy fields manually, so which is a time consuming, labor intensive, and sometimes unsafe due to exposure to the pesticides and harmful insects. So moreover, manual observation often leads to inaccurate assessment of crop growth stages and yield estimation. So to address this issue, our work proposes an AI-based system that uses the deep convolution neural network to automatically identify the paddy growth stages from images. So here we use the efficient net V2 model for accurate feature extraction along with a semantic stage mapping mechanism to standardize the predictions across the different data sets. So additionally, we introduce a confidence-based yield readiness index to estimate the crop maturity. The system provides a scalable and reliable solution for precision agriculture. helping the farmers to make better decision regarding irrigation, fertilization, and harvesting. So in this regard, in this research, we chosen the paddy crop because in India, most of the states cultivating the paddy. So in this work, unlike existing methods, in existing methods, they rely on the single source or limited data sets only. But we use a combination of multiple public data sets along with the additional data to improve the real world generalization. So most existing studies focus on the tasks like disease detection, crop classification, using a single stage images only. In contrast, our model handles the multi-stage paddy growth images and maps them into the standardized growth stages using a semantic stage mapping approaches. So we go beyond the classification by introducing these confidence-based yield readiness indexes, which provides an interpretable estimations of crop manually. So overall, the system bridges the gap between the visual growth stage detection and practical yield estimations, making it more useful for the real-world agriculture decision making. So in this work, we collected the data sets from different various public data sets for IP 102, and we are also having our own data set also we collected. So in the past decades, the paddy crop yield prediction and growth analysis, these things already based on some irrigation, some like rainfall on the rainfall data sets or some soil conditions, environmental conditions. Based on those things, so the existing algorithms works. We in our literature survey, we identify such algorithms like support vector missions. But here in this proposed work, so the proposed system introduces an end-to-end AI framework for automated paddy crop growth stages identification and yield readiness estimation using deep CNN. The framework processes raw paddy plant images. It extracts the discriminative visual features and classifies the images into the data specific classes. Here, if you observe this proposed model, you can see here. And this subsequently maps these classes to the standardized paddy growth stages. So the high level feature vector learned by the network, the efficient net V2 employs compound scaling to balance the network depth, width, and resolution, allowing the model to capture the fine-grained paddy plant characteristics such as leaf texture, pancal structure, and color variations. The extracted feature vector is passed through a fully connected classification layers to predict the class logits. The predicted class probabilities are obtained using this softmax function. The model also trained here. The model training is performed by maximizing the class weighted categorical cross entropy loss to handle the dataset imbalance as well. So the final yield readiness score is computed, and which ensures that high confidence predictions yield more reliable yield estimates. This model evaluation is conducted using the classification accuracy and loss metrics. So here, these are the results we obtained from the model. So we used the heterogeneous data sets and addressed the inconsistencies using pre-processing and weighted techniques. So the model shows the stable learning with the minimal overfitting. So you can here observe that the model shows the stable learning with the minimal overfitting and strong performance across the stages. Even in the training and validations curves also, if you observe here, it indicates the stable convergence and reliability. So here the higher confidence corresponds to the higher yield readiness, which aligns with the real world expectations. So we accurately identifies the stages in different aspects. So here coming to the final conclusion of this project. So even in future also, so these AI and ML deep learning applications will play prominent role for the agriculture. So it will support the farmers. Our work also supporting the farmers in future. So they can use these work for the targeted spray. So instead of blanket spray, and they can use this work. And this effectiveness as of this proposed approach was verified in terms of conducting the existing experiments, visual analytics, and real-time implementations. So we will also provide some Flask-based web applications and mobile applications also. So that means by using this research, they can develop such kind of web applications and some edge computing applications as well they can develop and they can use. So that is the future work of this research. So that's the end of my presentation. So you can ask any queries in this regard.
A quick question.
Yeah, madam.
Can you give a brief about evaluation metric that you used for the yield prediction?
So
In one of the PPT, I saw confidence score, right?
yes, madam.
Yeah. So can you brief more about that? Have you chosen only the confidence score? Why not the rest of the evaluation metrics like RMSE, MSE?
Yes, madam. Yes.
Please go ahead.
Yeah, this one, right, madam?
Yeah.
Yeah, madam, especially here in different stages, crops in different stages, we collect the different types of images. So those images, there is no relevancy. In earlier stage, the images we may not predict the yield. Later stages, we can predict it. So that's why we compare those images. So we make it more accurate. That's why we chosen this confidence scores.
Have you tried with any other metrics for the result prediction, result validation,
Yeah,
apart
actually,
from confidence score?
yeah, actually, in different papers in the different works, they have used in different metrics like the mean scores and different others metrics they were used, madam. But here we use this one.
Okay, that's fine. I'm good.
Yeah, thank you.
Hello, Srinivas.
Yeah, yeah, ma'am.
Yeah. Okay, I was just confused for one case. I cannot see the category of the paddies because in India there are various categories of paddy. The biological names are like Sharmati, PR126, CO45. These are the
Yes,
different
please.
categories of paddy, and based on there are more categories as well. And based
Yes,
on the category also, they have different time duration for seeding, for pruning, and
yes, madam.
flowering. So if that is not considered here, I am not sure how you can generalize, that flowering period across all the paddy crops.
Yeah, yeah, madam. Here in this choose only BT612 seats, madam. And that is the category we worked on that only, madam.
Okay, so are you planning to work on more categories? Because then this research would be very specific to one particular type of crop, isn't it?
Yes, madam. Yes.
And one more thing, no justification is given, like why you just selected CNN models and how your database would work on different kind of models. Like other models are also available in AI. So why just the selection of CNN? Then just was in the same.
Yeah, madam. So other models mainly they work on that categorical data, some numerical kind of data. So by process those data, it will make the predictions. Here we are capturing the images in different stages. So for that purpose, we have chosen this CNN model. So these models are very accurate for analyzing the images, madam, images data and extracting the features from the images.
Okay, and what particular algorithm are you using for extracting images or filtering the noise in the images?
Yes, madam. This efficient net V2. So we have some pre-trained models for pre-processing these extracting images from image to extracting the features, which whatever the features we are required, like that color combinations, green color combinations of.
Yeah, but the issue is that every image that you get from the public database, as you mentioned, that you use public database as well as your own as well. But public images might not be that clear, or the quality of the public images might be not efficient for the use in the study. So have you used any algorithm for the filtration?
Yeah. We, along with the public data sets, we are also collected some data, madam. It's a public data set as well as our own data set also we use it, madam, here. So already those public data sets that pre-processing and everything have done and they prepared for ready-made. So we added our some data sets for some sample of images also we added our from my end also.
Mhm. Oh, yeah, thank you.
Yeah,
That's
ma'am.
awesome.
Thank you. Yeah. Can I stop my PPT?
Yes.
Yeah. Thank you.
Thank you, Mr. Srinivasa, for your presentation. Now we have Shilpa Gujjar presenting computational and experimental analysis of compact wind turbine diffusers with curved converging diverging sections and extended uniform throat. Ms. Shilpa, are you present? Ms. Shilpa, are you there with us? All right. Mr. Kian, are you present with us right now?
Yes, I'm present. Yes.
All right. I'll introduce you and then you can start your presentation.
Okay, thank you very much. Can I continue?
Now we have Kian, sorry if I mispronounce this.
It's okay, no problem.
Jazairi presenting transparent dropout prediction in higher education using explainable AI. Decision support for policymakers.
Yes, thank you very much. Let me share my screen. Yes. Can you see my presentation, please?
Yes, it's visible.
Okay. Yes, hello everyone. Hello, ladies and gentlemen. My name is Dr. Kian Jazairi from Cyprus International University. Today I'm going to present our mutual work with Dr. Damla Karagözlü and Dr. Ahmet Adalia from the same university, MIS department. Transparent dropout prediction in higher education using explainable AI. Decision support for policymakers. So student dropout is not caused by a single factor. Rather, it emerges from the interaction of academic, institutional, and socioeconomic conditions. So this attrition creates financial burdens for institutions, reduces workforce readiness, and limits students' long-term opportunities. Especially science-based programs demand strong analytical and quantitative skills, which can increase student cognitive load and disengagement. Despite advances in predictive analytics, several gaps remain here. Many studies rely on synthetic oversampling techniques such as SMOTI, which may distort real educational patterns and weaken interpretability. Additionally, interpretable modeling approaches remain underutilized here, and cross-disciplinary analysis across science-based majors are limited. So there's also a lack of systematic investigation into explainable patterns that could inform institutional policies. So what our study does, this study aims to develop an interpretable and policy-relevant machine learning framework to predict student dropout. We investigate whether cost-sensitive learning provides a more faithful solution to class imbalance rather than synthetic resampling or oversampling. We also evaluate how accurately demographic, academic, and financial features predict dropout across science-based majors. And finally, we explore which factors drive dropout risk and how explainable AI reveals actionable patterns here. So the study uses a benchmark dataset from the Polytechnic Institute of Porto Alegre in Portugal, containing 4,424 student records and 35 variables, academic performance, demographic attributes, socioeconomic indicators, and macroeconomic factors. So the data set exhibited class imbalance here. We had more continuing students and less dropouts. So this was addressed using cost-sensitive learning rather than synthetic oversampling. And this approach preserves authentic data distributions and improves explanation reliability. We evaluated several machine learning models known for robustness and scalability, including ensemble tree-based methods like CatBoost, XGBoost, and logistic regression. The dataset was split using stratified sampling, and five-fold plus validation was applied to improve the generalizability here. And also, those machine learning models are just like black box models. So we had to add explainability. Explainability was achieved using Shapley additive explanations or SHAP. So this method provides theoretically consistent feature attributions and enables both global and instance level interpretations. So among the evaluated models, cost-sensitive XGBoost achieved the strongest performance with an accuracy of 89.6% and an area under the curve of 0.934, which is close to perfect. Here is the SHAP analysis, the SHAP B-swarm plot on right and SHAP bar plot on left. SHAP analysis revealed that academic engagement, financial compliance, and scholarship access are among the most influential predictors, most influential predictors. These variables reflect both academic commitment and financial stability, highlighting that dropout risk is shaped by structural conditions rather than isolated characteristics. And this figure is very important, the SHAP dependence plots for individual features. Here you can see the SHAP dependence plots, which reveal how individual variables influence dropout risk across the value ranges. Here in plot A and here in plot C, the number of approved curricular units show a strong protective effect. As it grows, the dropout probability or the dropout SHAP value decreases, almost linear. When this approved curricular units in the first and second semesters are increased, the SHAP values for dropout decrease. In the plot B, we can see students demonstrating tuition compliance experience a sharp reduction in risk. Those who had tuition are in less danger of and risk of dropout. Those who didn't pay their tuition are more likely to drop. Plot D here suggests a threshold effect in second semester grades, where performance improvements beyond a certain level lead to noticeable risk reduction. Those with higher grades, this is Portuguese system of grading, out of 20, those of grades above 10 and more towards 15 and more have less dropout risk, but those with 0 grade have higher dropout risk. In Portuguese, you either get 0 or above 10 in Portugal. We don't have something in between. And in plot E, you can see structural differences across different majors, course types, majors, programs of study. And in plot G indicates the scholarship support. When you have a scholarship, you are less at risk of attrition or dropout. When you don't have a scholarship, you are more in danger of dropout. I want to just re-emphasize this major or program. We call it course, but it's like the major of study, the program. So we find a U-shaped relationship between program science intensity and dropout risk. So students in moderately science intensive programs exhibited higher dropout risk. Those students in easier program or more difficult programs have less dropout risk. So this suggests that mid-level difficulty programs may lack adequate support structures, indicating opportunities for targeted reforms in early science education. So I'm coming towards the end. I just want to make a few suggestions to the policymakers here. Our proposed framework enables transparent early warning systems that can support targeted academic and financial interventions. By identifying structural risk factors, institutions can improve retention while promoting equitable outcomes. These insights contribute directly to the United Nations Sustainable Development Goal 4 by supporting inclusive and quality education through data-informed policymakers. In conclusion, our study demonstrates that interpretable machine learning can provide both strong predictive performance and actionable insights for higher education decision makers. Cost-sensitive learning preserves data integrity while improving risk detection. Explainable patterns here reveal the structural dynamics affecting student retention. So a future world may focus on multi-institution validation and integration into real-time decision support systems. Yes, that was my presentation. Thank you very much for your patience, and I can answer your questions. Should you have any questions, or later on, you can also direct your questions to my email. This is my email address. Yes, thank you very much.
Hey, Kian, thank you for it's really good presentation. I have one question with respect to imbalanced data set. So how you handle the imbalanced data set? As you said, this is completely imbalanced data set. So which are the different techniques that you used, and which one is the final one used for this handling the imbalanced data set? Can you elaborate?
Yes. Thank you for your question. There are some techniques called SMOTI, or synthetic minority oversampling technique. In such techniques, just synthetic data for the presented class is produced, so the two classes become equal. But when you want to work with explainability, synthetic data distorts the explainability. Introducing synthetic data is not a good practice when you want to work with explainability. So we employed cost-sensitive learning. In cost-sensitive learning, different coefficients are assigned to prediction errors, or to mispredictions from different classes. So if a misprediction of dropout versus non-dropout is made for the majority class, it has less penalty. For minority class, it has more penalty. So by adjusting two different cost functions for two different classes, you actually favor the underrepresented class, and you punish the overrepresented class. And this way, without introducing any kind of synthetic data, you handle this class imbalance. Could I answer your question? Hello?
Yes, Kian.
Okay.
Thanks. I'm good.
Thank you very much. Yes. Thank you.
Hello, Kyan. Hello, am I audible?
Yes, you are audible.
Okay, so Kyan, I was just curious about like mm, uh, the technique that you used for explainability. I can't find any justification for that. Like there are other techniques as well available, like Great Cam and Line. But do you like have any justification for just using SAP for explainability?
SHAP is the most popular one. We also have other techniques like ICE, individual conditional expectations. When we use SHAP, let me again share my screen. When we use SHAP, it allows, I will share my screen again. Yes. When we use SHAP, it allows a holistic general view and a feature level view. You see, this is global view, this is individual feature view. The reason that we employed SHAP was to give us the opportunity to look at all features and compare them generally, and then go to each feature one by one in a you see individual level. What ICE does, ICE just goes to individual levels. It keeps one of the features, it keeps all of the features constant, and it changes one of the features to see the effect of that change in that feature to the overall output or to the overall target. So ICE is only individual level. We have also LIME, local interpretations. LIME is also individual level, but SHAP is kind of a combination of all. You see, these are also not all the SHAP plots. We also have SHAP waterfall plots and force plots for each student one by one. So the reason that we selected SHAP was it was more comprehensive. It gives you actually every tool to view, you see all your features all together to see which one is more important, which one is less, which one is less, then which direction of that feature. You see here, when the approved curricular units is red dots is for higher values of this variable, this feature, blue ones are lower variable of this feature. You can see the direction of the effect. When we have higher values in this feature, it affects a lot the dropout probability, and it drops it a lot. So it gives you, it's like a very comprehensive toolkit. It gives you holistic view. You can compare features here, then you can go inside each of the features. For example, you can see that you see when the students pay their tuition, what differs when they don't pay their tuition. So SHAP is very general. SHAP is very, very comprehensive. That is the reason that we decided to go with SHAP, but other methods also exist, like ICE, LIME, and others.
Okay, thank you.
Thank you. Thank you very much.
Are there any other questions?
Yes. Thanks for the presenter. I have one question. After separating your data set, on what data did you use smooth? I see that we use
I
18%.
didn't use a smart. We didn't use a smart. We used cost sensitive learning. We didn't use a
Okay.
smart to not to introduce synthetic data into our data set because synthetic data distorts the explainability. When you want to do explainability, it's good that you don't introduce synthetic data into your data set.
Yeah, I have one question.
Please, yes.
Which is the most significant variable?
Oh, let me show you. Let me just show you. The amount of curricular units. No, not this one. The amount of, let me stop this sharing. Open my presentations. Yes. This is the most important feature. The amount of curricular units approved, or simply the number of courses passed in the second semester. You can see that is the top feature, most important. So the number of courses that the student pass and the number of credits, curricular units that the student passes in the second semester is very important here. Next is the tuition fee up to date. If they're up to date with their tuition fee, if they have paid their tuition fee. Next is the number of curricular units passed in the first semester. Next is the grade of the curricular units in the second semester. This is how many units passed. This is what is the grade. Next is the program of study, then age at enrollment, then the scholarship holder status, then these features, I can tell you, are not very important anymore. Mother's qualification, application mode, father's qualification, unemployment rate, GDP, these are not very important. As you can see here, I can say up to here are important. Here,
Yeah,
still
I can see.
important, but these are not important. Yes.
I can see the graph, but is there any statistical parameter which shows like Z score or standard deviation which shows
We
it?
didn't perform that. We didn't perform statistics. We just left everything to SHAP to visualize. But in a future study, we can also perform uh, statistical approaches. Yes.
Okay, thank you.
Thank you. Thank you very much.
Thank you for your presentation, Mr. Kim.
Thank you very
Now we
much.
have
Thank you very
Priyanshu
much.
Raj presenting early detection of crop disease from degraded field images using quality-aware FFD-net denoising and swing transformer classification.
So, good morning, all of you.
Good morning.
Okay, are you guys able to see my screen?
Yes.
Okay, so my topic is early detection of crop disease from degraded field images using quality-aware FFD-net and swing transformer classification. So here we go. Early detection of crop disease is vital for reducing crop loss, minimizing chemical use, and ensuring food security. Yet, traditional manual inspection is limited by subjectivity, errors, and timing issue. Although deep learning models such as CNNs and Vision Transformer trained on dataset like Plant Village achieve over 95% accuracy, their performance drops significantly in real-world conditions due to image degradation like blur, noise, and poor lighting. Experiment shows a 12 to 35% accuracy decline with increasing low quality images, highlighting a robustness gap, while existing work focuses on augmentation and model design. Advanced denoising methods like FFTNet remain underutilized. To address this, a robust framework combining FFDNet based denoising and swing transformer based feature extraction is proposed to improve performance on degraded real world images. So as you can see, when we run the ResNet model on a clean data set, the accuracy goes to 95%. And the F1 score is approximately, it crosses 95, the accuracy, and the F1 score is approx 95. But once the data set is degraded and the noise is introduced in the data set, the accuracy and F1 score drops to 70%. Same with swing transformer when there is no FFD-net. FFD-net stands for fast and flexible denoising network. So as you see, when we combine FFD-net and swing transformer, again the same model which was giving a lower accuracy on the degraded images gives a better accuracy. So coming to the problem statement, to design a robust plant disease detection pipeline that adapts to low quality inputs through adaptive pre-processing and advanced model architecture that provide accurate, explainable, and field-ready disease detection with treatment recommendation. So motivation, as I told you, there are a lot of CNN and ResNet models that works on the data set like Plant Village. But the problem is those data sets are like lab-based data set. They are very clean. And when it comes to real world farm condition, images captured by farmers are often low quality due to poor lighting, low resolution, motion blur, and etc. So existing model trained on clean and high resolution images saw a sharp decline in accuracy when tested on degraded field images. So there has been no existing work that combines FFDNet for denoising, swing transformer for feature extraction, and LLMs for contextual reasoning. So coming to the dataset description, our dataset that we used is Plant Village Kaggle dataset, and it consists of 54,306 leaf images, whereas the crops covered in these datasets are tomato, potato, apple, and etc. And the disease covers are blight, rust, mosaic virus, and leaf mold. Now it has a diversity of data set like covers fungal, bacterial, viral diseases, whereas we have also included healthy classes present for each crop that supports binary classification. Now, why did we prefer this data set? Because it has been used in hundreds of research papers and it is a large size consisting of 54,000 images. Coming to the literature survey, as you can see, there are plenty of work done on this, but these all models work and gives higher accuracy based on the high quality images. But when you reduce the quality of the data set and the quality of the images, and when you add a noise like Gaussian noise, median noise, then the accuracy decreases. So coming to the proposed work plan, first we did a baseline setup where we trained a ResNet on a clean image and then tested with degraded images. So we got a baseline accuracy. Then we did the pre-processing like removing outliers, corrupted or irrelevant images, resizing, normalization, and then we did denoising. So we used FFD-net to extract the important features from the low quality images. And then we used deep learning models like Swin Transformer and EfficientNet in order to classify the disease. Then we used metrics like accuracy, F1, PSNR. PSNR stands for peak signal to noise ratio. So with or versus without denoising, we check the evaluation matrix, then confidence score and heat map. And then once you get the classification, we have integrated LLM so that it will explain you that once your crop has some disease, what action to take next. And then deployment as a web interface and a mobile app. So coming to FFDNet, what it does is fast and flexible. FFDNet stands for fast and flexible denoising. So what it does is any low quality image, it map it as a good quality versus the noise, sum of good quality and noise of the image. So it assigns a sigma value, a constant to the what level of noise has been captured in the image, and based on that, it extract the features. Now coming to deep learning for plant disease detection, we have sticked with two models. One is EfficientNet and one is Swin Transformer, and we used our low quality image data set also for both the models, and then we had a comparative study. Now LLM integration. This is a very important part because once you know what the disease is, once the farmer comes to know that what the disease is, then the next step that is very important is what action can be taken in order to counter that disease. So here we use large language model in order to convert the technical outputs of the vision system into actionable agriculture advice for farmers. We have also did severity calculation. Severity means how much like damage has been done to the crop. So what we are doing is we are taking a image and we are mapping it into a binary classification where you can see the part that has been the area that has been already infected is converted into one like white, and the healthy part is converted into zero, which is low. And the formula that we are using is percentage of area infected is affected disease area by total leaf area into 100. These area are basically pixel values. Okay, so the architecture diagram. So as you see, our entire model treats entire data set as a low quality image. First, it does a image quality check. If it is a low quality image, low quality means image having low brightness, image having less resolutions. So based on that, FFD net denoises the image, and then it improves it into higher quality. Then the image goes into the features goes into the CNN models, the EfficientNet, the Swin Transformer models, and then it does the feature extraction. And based on the feature extractions and all, it classifies the disease. And after the classification is done, it uses LLM reasoning in order to provide the final output, like what action to be taken. This is the confusion matrix in which you can see like almost we have got mostly correct, only certain amount where you can see like it is misclassified like tomato healthy, and then tomato spider is misclassified. So here you can see the output. We compared efficient net V2 model versus swing transformer model. And as you can see, accuracy, precision recall, F1 score, everything, swing transformer is ahead with efficient net. Now there is a question comes, why swing transformer over efficient net? So the answer is, when we scale up the data set, right now the data set is 54,000, though it is a very big, but when it comes to real world, when we scale up, the data set will increase with a vast number. And when we scale up the data set, the accuracy of efficient net drops, but swing transformer stays constant. And the final output, the swing transformer, is a better model compared to efficient net when you scale up the data set. Here you can see our model trained with 20 epochs, and the loss, validation and training loss decreases as the epochs increases, and it is vice versa with the accuracy. As the number of epochs increases, the training and validation accuracy increases. So references for our project, and thank you for the presentation. Now we can move ahead with the question part. Any question, ma'am, sir?
Hello, Priyanshu.
Hello, ma'am.
Yep, I was just, trying to understand, you haven't covered much about the outcome part, the recommendation part in the presentation. Why is that so?
Sorry, can you come again? You're not audible.
I was just wondering, the presentation was more about the model and the accuracy of the model, but I think you missed that LLM recommendation part, how that is generated and all. There was no much explanation.
Actually, ma'am, this is the LLM part is the add-on part. I'll share the screen again. Okay, so as you can see, the last thing, LLM integration, it is just to help the farmers to take actions. And coming to explaining of this, here you can see that we have used multiple prompts in order to train our LLM, where the prompts are like what disease it is, if this disease is having this much of severity, then what action to be taken, what pesticides to use. And based on that, we have a data set in which we have multiple prompts, and based on those prompts, what output should be shown to the user.
Okay, thank you.
Thank you. Any other question?
Dr. Rana, do you have any questions?
No, I have already asked. Thank you.
Okay. All right. Thank you, Priyanshu, for your presentation. Now we have Saqib Hussain presenting efficient quantum resilient homomorphic encryption for scalable cloud data processing.
Hi, good morning, everyone. My name is Saqib Hussain, and I will be presenting the paper. Just give me a minute, please. I'll just finish it. I hope my screen is visible to everyone.
Yeah, it's visible.
Okay, thanks so much. So, hi everyone, my name is Saqib Hussain, and I'm from Bennett University. Today, I'm presenting my work on quantum resilient homomorphic encryption for cloud computing. So, the core problem which we face in this is the quantum computers can break RSA and ECC using Shor's algorithm. making most cloud security useless. Our solution is fully homomorphic encryption system built on lattice-based cryptography that lets the cloud compute on encrypted data without ever decrypting it. And you can see the ways we work on it also. So the literature review which we have proposed, and we have noticed the gaps which have been, as this topic has already been studied by a lot of people, but as much it's not gone in as much depth as it is supposed to. So the prior work gave us like LWE, ring LWE, and Gauntry's FHE, but no one combined all of these to just have use it for dynamic key generation, key management, and generation at cloud scale. So that's our gap and our contribution to this paper. So the system architecture is divided into three parts, or we can say three modules, which are client encrypts the data, cloud server computes on it without decrypting is scaled, via Kubernetes, and key management rotates keys continuously. That's how the data stays encrypted, and it's already end to end. So it makes the data safer and much more easier to transport also over the cloud computing. So the methodology and the theoretical foundations. The security is grounded in LWE and ring NWE hardness, resistance to quantum attacks. We also follow NIST post-quantum standards through Kuber KEM, which makes that the data is even more secured over the media of cloud computing, and it's also like from the end-to-end user as well. And encrypt on client, compute on cloud, decrypt on client. Key refreshes throughout every process, which makes it very much unpredictable from the attacks and very difficult to crack through also. And this was the experimental setups you can see. We tested on a Kubernetes-based cloud simulation. And I would like to clarify this part again, that we have used a simulation rather than actually implementing it, so that we could have studied much larger data and much faster also. So these were the three VM sizes we had decided to go with, and it went up to like 100,000 records and 30 runs each for statistic reliability. And the results when we had run all these VMs were these. So 60 to 70% latency overhead over classical HE. And throughput drops about 25%, and memory increases by 60%. But horizontal scaling with Kubernetes compensated efficiently. The trade-off is acceptable for the quantum security guidance return. So basically, somewhere or the other, the data becomes data is like horizontally, it's not we can say scaled up as much as it should be, but the level of security which we get in this is much higher than the ways we get in normal ways. You can also see the VM we have used, and you can see the two different sizes we have used for the differentials of data sets in the large. We can see that how much the classical HE was taking the time to process all that and encrypt it, and the latency. Sorry, the latency we had observed, and you can also see the overhead percentage between 60% all the way to 88%, which was a jump because of the amount of data set we took. So we took a smaller data set, which actually made it a better result. The main limitations are computational overhead and larger ciphertext sizes. Future work focuses on GPU acceleration and algorithm optimization. So these are the points which we'll be working in the future so that we can get even better results than we have right now. Because somewhere or the other, right now, to deal with the quantum on the cloud basis, our GPU processing is not up to the mark, we can say, because as these are some new techniques which require even higher computational levels, so we just require higher GPU acceleration also to work into them further. Sorry. So in this PPT, we have just delivered a practical NIST aligned quantum resilient FHU framework that scales on real cloud infrastructure, and security guarantees justify the overhead. And this is a solid foundation for core cloud computing in the quantum post era. As you can already see, the parts we have divided it into the post-quantum security, practical performance, dynamic key management, and NIST alignment. We have used we have already used the parts where it's LW and ring LW hardness ensures resilience against both classical and quantum adversaries, and 60 to 70% latency overhead is offset by horizontal Kubernetes scaling competitive operated throughout maintain. Dynamic key management, continuous key refreshes minimizes long-term exposure in high-frequency multi-user cloud environment. So as we have just also used like VM over there, so we are just like made it more secure by just generating queues on each step, which makes it easier for the users to like have the security with them, and it's also difficult for the attackers to attack on the data as the key continuously changes. And the framework adheres to NIST post-quantum cryptography standardization guidelines by the KOBRKI. These are the references which we had used, and these are the relevant references which consist in our research paper. Yeah, and thank you so much. Thank you for your time, everyone, and that was my presentation on the topic efficient quantum resilient homomorphic encryption for scalable cloud data processing. If any questions, I would like to know.
Hello, Shakib.
Yeah, good morning, ma'am.
Yeah, good morning. It was an interesting topic, I must say.
Thank you so much, ma'am.
The question is that 60 to 70% of overhead is, I think your algorithm can do better than that. So what would be the suggestions that you can give to make this, the results more acceptable in terms of offset?
Ma'am, your audio is break. Can you please repeat the question? I'm so sorry.
The question is that, as you showed, that the efficiency is 60 to 70% offset, isn't it? So the question is that, what is your recommendation in future as an improvement in the algorithm to give better performance?
Okay. First of all, thank you so much for asking that question. That's a really interesting question. And I would like to say there are a lot of points because of the resources availability, but I will just break down it. For the first part being the GPU acceleration now. The GPU acceleration which is used in the nowadays computer is not as far up to the mark to handle the data according to the quantum basis, as the FHE operation involves massive polynomial multiplications, and GPU are built for parallel math operations. They can handle these like if we have more GPU acceleration, as right now also we use some GPU acceleration, but it was not enough as of the coming time. But in the future times, when we get more better GPU acceleration resources, we can just get the data as the CPUs to work even 50 to 10 to 50% more accurately. And this is the single biggest potential improvement, and is actively being researched also now. And we can also use like there are some algorithms which can be optimized to even get better results, but those are still being underworked right now, like number theoretic transform, which is also known as NTT. That's a mathematical technique which is used to like for polynomial multiplication, and the core it is also used as a core in operating a ring LWE. So if that people are also trying to work on it to make that NTT technique even better, so that they can get better results for these competitions as well.
Okay, thank you. That answers my question. I do not have any further questions.
Thank you so much. Does anyone else have any other questions? Okay. Thank you so much for your time. Thank you so much for your time, everyone.
Thank you, Sakin, for your presentation. Now we have Ishwarya presenting government notice verification system using blockchain technology. Ms. Ishwarya, are you present?
Yes, ma'am. Am I audible?
Yeah, you're audible.
Is my screen visible?
Yes.
Good morning, everyone. I'm Aishwarya from Sono College of Technology, Salem, India. Today, I'm going to present our project titled Blockchain-Based Government Notice Verification System. This work focuses on solving a real and important issue in digital communication, the circulation of fake or tampered government notices, especially in educational institutions. Our aim is to provide a secure and trustworthy way to verify whether a notice is authentic or not. And in today's digital environment, official notices are commonly shared through websites, emails, portals, and social media platforms. While this improves communication speed, it also creates a serious problem, so that the official notices can be forged, altered, or distributed in a fake form. This also can lead to misinformation, confusion, and a loss of trust among institutions. So, to address this issue, we propose a blockchain based verification system. And in our system, every official notice is converted into a cryptographic hash and stored securely on the blockchain. And While the original file is stored in IPFS, which is a decentralized file storage system, and this also allows user to verify the authenticity of notices in a secure way. And The main objective of our projects is first to ensure that every official government notice is tamper proof, and second, to provide a decentralized and transparent verification mechanism using a blockchain, and third, to automate trust and validation using smart contract, and to securely store notices files using IPFS and maintain searchable metadata using MongoDB. Overall, the goal of a system is to improve trust, authenticity, and reliability in government communication. And and in the existing system, official notices are generally stored in a centralized database or distributed through website, email, and document without a strong verification mechanism. This leads to several limitations. For example, centralized storage can be vulnerable to tampering, unauthorized access, and a single point failure. Also, users often have to manually trust the source of the notice, which is not always reliable. To overcome these problems, we propose a blockchain based architecture. Our proposed system improves the existing approach by using blockchain for immutability and trust, smart contract for automated verification, and IPFS for decentralized file storage, and MongoDB for efficient retrieval of the metadata. This ensures that once a notice is uploaded and registered, it becomes traceable, secure, and resistant to tampering. And this is system architecture of the proposed system. The architecture is divided into several major layers, and at the top we have the government admin, who is authorized publisher of official notices. The admin interacts with the system through the front end layer, which is developed using React, HTML, CSS, and JavaScript. And the front end provides modules such as login and authentication, notice upload, notice viewing, verification. Once the notice is uploaded, the request is sent to the backend layer, which is built using Node.js and Express. The backend is responsible for handling the core system logic, which is user authentication, file upload handling, cryptographic hash generation, blockchain communication, IPFS integration, and MongoDB operations. And when a notice is uploaded, the system first generates a SHA-256 hash of the file. And this hash acts like a unique digital fingerprint of the noticer. Um, After generating the hash, the original notice file is stored in IPFS, which is a decentralized storage system. This is useful because storing large files directly on the blockchain is not efficient. At the same time, the system stores the file hash and related metadata in the Hyperledger fabric, which acts as the trust layer of the system. The blockchain stores details such as notice ID, uh, timestamp, file hash, and IPFS reference. And the smart contract ensures that only authorized users can publish notices and that all notice verification rules are enforced automatically. And in addition to that, MongoDB is used only for convenient and fast retrieval. The actual trust and authenticity always come from the blockchain record. So overall, the architecture combines security, decentralization, and efficiency. And the this is the core part of the project, which is a smart contract functionality. The smart contract is one of the important because it defines the rules for how notices are registered, verified, and retrieved. And uh, its main function include registering a new notice, verifying notice authenticity, controlling access, and retrieving notice records when needed. And in simple terms, the contract ensures that only authorized government users can upload. Once the transaction is committed to the blockchain, the record becomes immutable, which means it cannot be modified without detection. And this removes the need for blind trust and replaces it with the automated and system level trust. And this is a consensus mechanism. For this project, we selected a Hyperledger Fabric because it is a permissioned blockchain, which is more suitable for government and institutional applications. Unlike public blockchain, a permissioned blockchain allows only trusted and authorized participants to interact with the network. This is important because government notices will be managed by anonymous or open public nodes. Uh, Hyperledger Fabric provides several advantages for our use case, such as controlled access, better performance, lower computational cost, and stronger suitability for official organizational system. For this government notice verification system, Hyperledger Fabric is more practical and efficient choice. And our working flow is first, the government admin logs into the system and uploads the official notice document, usually in a PDF format. Once the file is uploaded, the system performs the following actions. First, it generates the hash of the file, and second, it stores the original file in IPFS, which gives us decentralized and secure file storage. Third, it records the file hash and metadata in the Hyperledger blockchain using the smart contract. Fourth, it stores non-sensitive searchable details in MongoDB for efficient access and display. After this process is completed, the notice becomes available for verification. And now, when an institution or public user wants to verify a notice, they can either upload the notice file or access the notice through the portal. The system then generates the file hash again and compares it with the hash stored on the blockchain. If both the hashes match, the notice is confirmed as authentic. And this makes the verification process automatic, secure, and highly reliable. And this is the flow diagram. These slides show the implementation interface of the system. We developed several functional modules such as user authentication, notice submission, pending approvals, and a blockchain transaction records. So this is the user authentication page of our website, and here user can log in using the username and password.
তুমি একবার এসো
Excuse me, Ishwarya.
জানি জানি জানি
Yeah.
সেটা তো জানি বাথরুমে আছি
You have 1 minute left for your presentation, so
তুমি
please
এসে
conclude.
Yeah, can I proceed?
Yes, yes. Just note that you have 1 minute left for your presentation.
Okay, thank you. And this is the verification interface, allows institution or users to check whether a notice is genuine. And here these are the submitted notices for approvals or pending for approvals, and how many votes have been voted for this. And see, these are the pending approvals which needs to be checked, and these are the approved news which is automatically published after the consensus mechanism. And this is the blockchain transaction section that acts transparency by showing that the notice has been registered in a secure and traceable way. And advantages of our proposed system is, first, it prevents tampering, and it ensures secure and transparent verification. And third, it reduces dependency on manual validation and human confirmation. And fourth, it increases trust in official communication. And overall, the system improves the integrity and trustworthiness of digital notice communication. And future scope is that or possible extension is integration with government portal, so that notice can be automatically registered and verified at the time of publishing. Another extension is cross-department verification, where one department can validate notice issued by another before they are distributed publicly. And so the scope of this project can go beyond notification verification to broader digital trust system. And in about conclusion and in summary, our work demonstrate how blockchain can be applied in a practical and socially useful way to strengthen trust in official communication. And thank you for your valuable time. I'd be happy to answer my questions.
Hey, hi, Aishwarya.
Yeah, ma'am.
I have one question with respect to storage. So you said that you're using IPFS storage, right? So I
Yes, ma'am.
know with that storage, it comes with some advantages, like it is a distributed and a cheaper storage that we have. But it also comes with some limitations, like if some node is not using for some period of time, then data may disappear, or node may delete the data. So there is again a privacy risk with that storage. So why you chosen IPFS, not other storage? Can you justify? Am I audible?
Yes, ma'am. Yes, ma'am. Ma'am, am I audible, ma'am?
Yes, you're audible.
Yeah, ma'am. And yes, ma'am, that IPFS does have some limitations, such as potential data availability issue. And however, we choose IPFS because its advantages are highly suitable for our system, because it's a decentralized storage, so it's not stored in a single server. This eliminates a single point failure. And second, it uses a content based addressing, ma'am, meaning each file is identified by its cryptographic hash. And this ensures that even the file is tampered with, it will not match the original hash stored on the blockchain. And third, storing large files directly on the blockchain is inefficient and costly. And IPFS allows us to store files off chain while keeping only the hash on chain, which improves performance and scalability. And regarding the limitations, to handle data availability, important files can be pinned or hosted on dedicated IPFS nodes. and to ensure that they are always accessible. And for privacy, sensitive data can be encrypted before uploading to IPFS, so only authorized users can access the actual content. So overall, IPFS is chosen because it complements blockchain by providing efficient decentralized storage, while the blockchain ensures trust and verification.
Okay, sounds good.
Thank you.
Thank you.
Yeah, thank you, ma'am.
Thank you, Shreya, for your presentation. Now we have Ichiro's Gangbo presenting intelligent network intrusion detection based on hybrid sampling techniques and deep learning approaches.
Hi. You can see my screen?
No.
Not yet.
Okay. And now?
Yes, it is visible.
Okay, thanks. Good morning, dear members, distinguished guests, and fellow colleagues. Today, we are honored to present our study entitled Intelligent Network Intrusion Detection based on hybrid sampling technique and deep learning approaches. Our presentation will be structured as follows. We will begin with an introduction, then present the motivation and research problem, followed by the scope of the study. Next, we will describe the dataset, explain the proposal model, discuss the experimental result, and finally conclude with future perspectives. In today's digital era, cybersecurity has become a critical concern. Modern networks are continuously exposed to increasingly sophisticated and evolved cyber attacks. However, traditional intrusion detection systems, particularly signature-based approaches, are no longer sufficient as they struggle to detect no or emergent threats. To address this limitation, our work explores the integration of artificial intelligence techniques, combine both machine learning and deep learning to enhance intrusion detection performance. Most specifically, we propose a hybrid model that leverages the strength of multiple approaches. On slide 4, we illustrate that machine learning based on learning from data is a subset of artificial intelligence, while deep learning based on a neural network is a subset of machine learning. Let us define. Instance, a dataset not seen during training. Which model improves intrusion detection performance? If you have F theta, a deep learning based feature extractor parameterized by theta, G, a classical machine learning classifier, if the performance of the F theta instance is greater than of G instance, then the hybrid model improves detection by enhancing class separability. In this work, we reconstruct the CIC-IDS 2018 dataset. We apply both machine learning and deep learning techniques. We evaluate the following modern CNN, CNN-STN, SGBoost, and a hybrid model. Performance was assessed with confusion matrix, F1 score, and AUC, area under the curve. The dataset used is CIC-IDS 2018. It is a benchmark dataset in cybersecurity designed by the Canadian Institute for Cybersecurity and was generated over 10 days. It rates for its realism, its diversity of attack types. The data was cleaned, reorganized, filled. A reduction strategy implemented in Python allow us to extract daily attack datasets. After pre-processing, 18% of the data was used for training, 20% for testing. To address imbalance, we apply smooth of training datasets. We evaluate CNN, LSTN, XGBoost, and hybrid model. And that we see that in this slide, benign class, 76,139 samples, 60,911 for training, and 50,228 for testing. And SSH brute force, we see that 569 samples, 455 training, 114 testing. This criteria is significant class in imbalance. That is our model. And so that you say 18% for training, 20% for testing, and we apply smooth for training the data set. After that, we compare the performance. Before smooth, highlight imbalanced data set, dominance of the benign class. After smooth, all class are balanced as 60,911 samples, which helps reduce model bias and improve learning. That is a confusion matrix. It allows us to identify two positive, false positives, two negative, and false negatives. It compares actual and predict value, showing correct and incorrect classification for the hybrid model we observe. If you see brute force attack, 109 correctly classified, 109 correctly classified, you will see infiltration attacks for model hybrid, 213 correctly classified. The F1 score is computed as 2 precision recall on precision plus recall. XGBoost achieves the best overall performance across most attacks. CNN and LSTM models underperform when used individually. The hybrid model improves results but remains slightly below XGBoost except for infiltration where it performs best. XGBoost and the hybrid model achieve the highest accuracy, 0.92. CNN and CNN STM show lower performance, 0.77 and 0.67 respectively. Although CNN and CNN STM achieve relatively high accuracy, they exhibit lower recall, meaning they fail to detect a significant number of attacks. In contrast, the hybrid model maintains high accuracy while improving recall to 0.92, which is crucial for reducing false negative. The AUC metric evaluates the model ability to distinguish between classes. The higher the IC, the better the performance. And that we say XGBoost at 0.992 and hybrid IUC with 0.99. XGBoost achieve the highest performance. The hybrid model remains a strong and reliable alternative. For conclusion, cyber attacks are become increasingly complex and difficult to detect. Our study demonstrates that XGBoost and the hybrid model are the most effective approaches. Both achieve IUC value exceeding 0.99. For future work, we propose integrating SHA for model interpretability, deploying the model in real-world environments, evaluating real-time detection performance. Thank you for your attention.
Do you have any future plans for adding more attacks?
I don't understand.
Do you have any future plans, future work, where you can add some more attacks?
Yes. We said that we use on our own computer to run the simulation in order to reduce the size of a dataset while preserving the same proportion and all daily attacks. To achieve this, we developed a software tool in Python. We rely on daily attacks to build a reference dataset based on this reference. The dataset is filtered and we verify that the resulting data still include and all the daily attack tips.
Okay. And for imbalanced data handling, you also use the SMOT, right? Why SMOT?
Yes.
Can you please justify? There are a lot of imbalanced data handling techniques are available. Why you chosen SMOT?
Okay. After SMOT, we have another model. We have Adacin, but we use SMOT because SMOT work in a higher class. And then we use SMOT to correct class imbalance, which can bias the model toward the majority class. However, SMOT can generate artificial noise overfitting. That's why we should be used with caution. Can I answer your question?
Yeah, okay. Thanks. I'm good.
Hello.
Yes, I'm good. Thank you.
Hello.
Hello, am I audible? Hello?
Can
Yes,
I ask him your
ma'am.
question?
Ma'am,
You
you're
you
audible.
you
Yeah.
listen me?
Yes, I'm listening. I'm good, I said. Thank you.
Okay, you're welcome.
Thank you for the presentation. Now we have Yavor Danko presenting modeling of educational role-playing games.
Hello, thank you. Am I audible?
Yes, you're audible.
Thank you. I will share my screen now. Do you see my screen?
Yes, it's visible.
You see my screen? Okay, thank you. So, Faculty of Mathematics and Informatics in Sofia University, and these are my co-authors from the faculty and from the Institute of Information and Communication Technology from Bulgarian Academy of Science. Video games are a popular form of entertainment in modern technological society, and this is because of their widespread popularity among people of all ages. And so video games have a significant impact on their users and are used in a range of applications. These educational video games combine the entertainment aspects of video games with pedagogical messages and didactic content. The primary goal of education video games is training or educating users or learners in a specific field of education while they play. The main challenges regarding these games are the design and modeling for creating role-playing educational games that are useful for learners and complement the educational process and program. To address these challenges, it is necessary to establish a starting point or model for creating such games, thereby significantly facilitating these processes. The focus of our paper is on the design and modeling of educational video games in the role-playing games genre. Educational role-playing games combine the set educational goals and tasks with entertainment elements of the role-playing genre. So this allows players to engage in role-playing and participate in the adventure as they acquire and learn the integrated educational content. Our paper presents 5 taxonomies of core concepts for describing educational role-playing video games that participate in the proposed 2-level meta model for describing these games. The development of such meta model would be beneficial for initiating the modeling, design, and development of these games. It will significantly facilitate both game design and implementation, which are usually intellectually challenging and time-consuming. So the main concepts of the meta model represent key aspects of the role-playing educational games and are organized into 3 detailed hierarchical levels. Due to space constraints, our paper presents only the first level of the taxonomy of 4 certain core RPG components. So the first meta model is regarding the world, which represents an interactive environment in which the scenario and learning elements are constructed. We see on this slide 7 components of this taxonomy. The first one are regarding the main characteristic of the world. The second is regarding the time. Of course, the third will be game physics, which includes physical interactions, collision rules, combat mechanics, if the game includes such interactions. The fourth element of the taxonomy is the environment. The fifth is environment objects and entity logics. The sixth one is interface, and the seventh is faction and society layer. The second meta model is regarding the educational issues. This taxonomy includes the knowledge domain and learning aspects in the RPGs. So this is the central component of the game, and it represents a taxonomy of embedded knowledge along with the corresponding learning-related components. So this meta model includes 8 components. The first one is the knowledge domain. The second is the content knowledge units. The third one is learning aspects, which includes the learning goals, learning tasks, and of course, for making such game, it must include the fourth element, which is the learning challenges and learning outcomes. And the sixth element of the meta model is the pedagogical use cases and learning scenarios, and of course, learning feedback. And the last one of the education issues taxonomy is the mappings and alignment. The third meta model is the taxonomy of the RPG quests, which represents a meta model for the design and construction of educational RPG quests. Quests are the primary missions or tasks that players or learners must complete to advance the game's story, implemented through the gameplay. So quests may be required or optional, represented as side quests, and at the highest hierarchical level in the taxonomy, the most essential elements are presented in 6 elements. The first one is the quest name and context, which are description of the quest. The second is the quest giver or the character which gives these quests. The third element of the meta model is the quest description, which includes very important information about the quest goal, game level requirements, game resources, play activities, and of course, the learning goal, which may be optional. The fourth is the quest challenges player activities, which include zone exploration, resource gathering, crafting items, and so on. The fifth is the quest progress. So the game must include such monitoring of the progress regarding current quest progress or completed tasks. And of course, when completing the quest, there must be quest reward, and in different games can be experience points and loot. The next meta model is regarding the game characters. So the taxonomy of the RPG game character is a meta model for the design of the main character that the player or learner can control in the game. In this sense, the first level of taxonomy represents the main characteristic of the character, which is the name identification. The second is avatar, which represents the detail about the avatar that give a unique representation of the character in the game. The third is regarding the actions which can be played by this character. The fourth is class, which is different in the games. The fifth is the possible skills, and the sixth are the properties of the character. And the last one is regarding the progress, which can be educational progress, milestones, and achievements. The last one is the taxonomy of the NPC in the RPG world that contains 8 divisions at the first level, whereupon each of them is detailed in the 2 additional levels of granularity. The first one is regarding the personal identity of the NPC. The NPC must be configured regarding the interaction styles, the language, the feedback which can give. Of course, when modeling such NPC characters, there must be some behavioral modeling and game role integrated in the game, and social and cultural interactions, which can be social cues, ethical considerations, and of course, it's very important to include the last one regarding the accessibility and inclusivity in the of the NPC. We also presented in the paper the relationships regarding the knowledge domain and other main RPG components presented in this slide on this diagram. In general, knowledge complexity defines components of sophistication. Yes?
Sorry to interrupt. This is just a gentle reminder that 1
thank
minute
you.
is left for your presentation.
Okay, I'll be finishing. So, as a result of this the presentation, we conclude that the RPG game could be personalized by adjusting task quest difficulty, modify content sequencing, and challenging times. And the achievement of target learning goals and knowledge gains is indicated in the character progress, which can provide data for the recent adaptation of feedback type and frequency. We also presented an example of using the meta model to represent a quest from a real educational RPG game, which is detailed in the paper. So this represents an example of the quest model presented. It describes only the main quest concepts. However, for the sake of the precise design model-driven game development, it can be detailed into 3 levels and interconnected with other elements of the RPG model, such as world, NPC, and game story. And as a conclusion, the paper presented the RPG model that can improve understanding of such games in educational context and help better design, develop, and integrate them into various learning environments. The application of this meta model is illustrated by the modeling quest detailed in the paper, and the detailed RPG taxonomy, organized into 3 hierarchical levels for each game component, captures numerous relationships among the component structural elements and can serve as a viable template for presenting design details in a structured manner. As a future research directions, we include expanding the model to deeper levels beyond the primary taxonomy presented in this paper. Additionally, a model for automatic design and generation of resources for education games should be developed as the next step, and this would enable the developers of learning games to focus solely on education aspects rather than on technical details such as programming, software architecture, and testing. The research is supported by the Bulgarian National Science, by the Project Motivate, and by the Project Summit. And thank you for your attention.
I
have a quick question. What is the motivation why you worked on this RPG model?
The motivation is because our team is working on different genres, and we conclude that the RPG will be our starting point for developing such meta model regarding this genre. And as a future work, we will try to expand the meta model on different genres such as simulation, educational games, puzzles, or strategy games. And this is for now.
Okay, sounds good. I'm good. Thank you.
Thank you.
Thank you, Mr. Yakov, for your presentation.
Thank you very much.
Now we have Shilpa Guzar presenting computational and experimental analysis of compact wind turbine diffusers with curved converging diverging sections and extended uniform flow. Ms. Shilpa?
Hello. Good morning, madam. Am I being audible?
Yes, you're audible.
Okay. I'm just sharing my screen. Good morning, all of you. So, can I start? Is it visible? My slides are visible. Hello? Hello?
Am I audible?
Yes.
Yes, your presentation is visible. You may please start.
Yes, thank you. So here, good morning, all of you. So my presentation or research paper is on computational and experimental analysis of compact wind turbine diffusers, curved converging diverging sections with extended uniform throat. So here, what is the diffusers? First thing is that mainly the small wind turbines are there, which are mostly utilized in case of urban areas where are the low wind conditions. But unfortunately, it is very much difficult to get the more power output from the small wind turbines or low wind conditions. So as well as we are facing the limited fossil fuel, there are limited fossil fuel reservoirs and rising global warming, which has been shifted us towards the renewable energy. And here is the small wind turbines, which can be used at low wind condition and in urban areas. So efficiency, or we can say power output from the small wind turbines can be increased or enhanced using the diffuser that is called the diffuser augmented small wind turbines. So again, there are different types of, we can say different designs and shapes of this diffusers for the small wind turbine diffuser, small wind turbines. So the problem statement for the particular research paper is the small wind turbines have low efficiency or low power output at the low wind speed and need performance enhancement. The objective of this work is to enhance the power output using the diffuser to horizontal axis small wind turbine and compare the CFD results and experimental results. Now, the methodology that has been implemented for this particular research work is the first problem identification, literature survey, then diffuser shape and geometry selection, then computational fluid dynamics, design of experiment, CFD analysis of DOE results, then again regression analysis, optimization, then manufacturing, wind tunnel testing, results and discussion, and conclusion. I think there is some disturbance, ma'am. I don't think. Hello?
Yes.
There is some kind of disturbance, ma'am.
Okay, I will look into it, but please continue with your presentation.
So here the design of the compact or short wind turbine diffusers are here DI, that is the inlet diameter of the diffuser, then throat diameter, this is the cylindrical throat, curved diverging section, flange height, and then the outer diameter of the diffuser. This is the ring or wind length which is covered over the small wind turbine so as to improve the velocity which is penetrating on the rotors of the diffuser. So I have done the computational fluid dynamics, computational study of the particular diffuser. This is the diffuser or wind length. And there, for that, the boundary conditions, that is the velocity inlet, pressure outlet, then turbulent intensity of 2.1%, then model used in CFD is KMMO ISST, then mesh size has been used as 5 mm. Number of elements, mesh type was dominant, skewness and was always less than 0.48. Mesh quality was about 0.89, okay, and here the Y plus value is always less than 5. So meshing, these are the meshing details. The axisymmetric part of the diffuser has been studied inside the domain. This is the boundary wall. This is the domain, rectangular domain, and this is the diffuser that has been studied in the particular CFD analysis. The full domain meshing, this is the full domain, and fine meshing used as the diffuser boundary conditions. With the help of design of experiments for 6 parameters and hello, there are 6 parameters and 5 levels. So here, so inlet diameter has been studied for the step of 10 mm. Then outlet diameter has been studied at the step of 10 mm. Then for the flange height, that is in the step of 5 mm. And again length L1, L2, and L3 in step of 5, 10, and 5 mm. It is based on the its sensitivity that has been done in the ANOVA analysis, sensitivity analysis. Then the regression, through the regression analysis, I got these equations, mathematical equations for the linear regression analysis, which were founding the poor fits. So that's why, because of the lower square value, we went for the second order regression. So this is the V global average velocity and velocity variation on the wind turbines. So here, with the help of quadratic regression equation or second order regression equation, it has been identified the R square value of more than 90%. So it is, we can say it is the best fit. Nice. So the wind tunnel testing for the wind turbines or the small wind turbine has been done in the aerodynamics laboratory for Department of Aerospace Engineering in Defense Institute of Advanced Technologies in India only, which was the subsonic wind tunnel. The comparison of the CFD and experiment results were done, and it has been identified that whatever the experimental CFD results that was identified, there was about 2.5% maximum variation with the CFD results, with the experimental results. So the conclusion is 25 short curved diffusers were curved plane diffusers having converging diverging sections and extended uniform throat between them are analyzed on the CFD results for this paper. From the results, it is identified that the global velocity is localized and 1.18 to 1.45% time has been increased as compared to that of the radial average velocity. Regression analysis and statistical evaluation study observed that the inlet diameter and throat length, along with their quadratic terms, are influencing the radial average velocities and radial velocity variation significantly. Also, after the optimization of the diffuser, the predicted results has been identified and the experimental results and predicted results variation has been identified and it was less than 5%. So this is my work that has been done on the small wind turbine diffusers, CFD analysis as well as the experimental study. So thank you. In case of any questions. Hello.
Dr. Preeti, Dr. Rana, are there any questions?
Those was the questions.
Thank you.
Thank you for your presentation. At last, we have Steven Saltos Minaya presenting user experience of deaf and hard of hearing students in institutional web platforms, case study at University Técnica de Manabí.
Okay. Okay. Good morning, member of the board. My name is Steven Saltos Minaya. Before beginning, I want to ask you a question. Who would you imagine life if you could hear the world around you? This is really the 4,000 of the people worldwide who suffer from hearing disability. Today, I will present my reason for the user experience data of hard-hearing student institutional with platform case student at Universidad Técnica de Manabí. Tutor Elba Tatiana Zambrano Solórzano. Yeah. Problem example, institutional platform is SA, virtual, and SIS. Last visual support out from the scene records, creating the schedule varying student for we hadn't decided. Justification. Institutional platforms are essential for staying and ministry producing and helping identify accessibility barriers made impossible purpose includes employment, than wearing anatomy and educational kit for students with hearing disabled or UTM. General object to evaluate the usage of students with hearing disability of the institutional platform LSA, virtual and SIS in order identification its ability vary or propose including improvement. Specific object. 1. Diagnostic autonomy comprehends and the use the SH virtual entities. 2. Identify critical barriers from sorting and the participant observation. 3. Describing difficulty in navigation, clarity, and visual support. 4. Propose multiple improvement oriented to accessible. Methodology. Mixed methods, integration for the quantitative structure survey and qualitative participant observation. Date. Quantitative component, a structure survey of the Google form, the discrete state analysis, the frequency on the percentage, and quantitative component, the participant observation in real situation. Scope is discrete, oriented to analyze of experience and actively vary of the institutional platform. Is GA, is virtual, CIS. Material untold. They were collected through an student survey of the Google form and participant observation in the FCE laboratory, student interaction with SH, virtual, and CIS. We recorded during typical tasks and tabulation in Microsoft Excel for quantitative qualitative analysis. Population and sample. Population. The population consists of the 7-8 students with hearing disabled screen in the inclusion Universidad Técnica de Manabí. Sample. The sample was intentionally select, including 10 participants with everything in hearing the loss level, mild, moderate, severe, and profound, and experience in the using institutional platform. Same. The same conditional is 10 intentionality. Selected participant at between the 18 and 15 years. Of diversity level of hearing loss. Hearing loss and classifications and mild. Difficult in noisy environment. Moderate. Records high age. Severity. New powerful hearing aid or sign language. And profound depends on sign language. 16% were the male and 14% female. Are active students and Universidad Técnica de Manabí with experience using institutional platform. Inclusion or exclusion criteria. Inclusion, age more is 20 years, active UTM student, diagnostic of the hearing disability, previous experience with platform, SH virtual OCs, comprehension of instruction in Spanish or language enseñed Ecuadorian. Inclusion, a student without experience with platform, inability to complete tasks, a refusal to give informed consent, medical or technological condition, the prevent participant. Note, this criterion do not discriminate. It is recognizing that some students might not master Spanish or sign language, due to previous education varies, and rarely that institution must add with adaptive methods. The working inclusion every note. Accessibility vary process and analysis. Experiment process. The surface was administered via Google Form to the 10 participants. Participant observation was the county is the FCE laboratory recording information dates. Participation interaction-wise, they perform typical TOEFL and SGA, virtual and CIS platform. Accessibility metric iteration. Response time, the time age student to the complete age task. Navigation errors, incorrect or repeat action that indicate confounded the interface. Need for support, frequency with they require certain assistance. Identified varies, categorized by type, navigation, content comprehension, lacks the visual support, and opting on the single language records. Result, statistical analysis. The feeding rival that half of the students archie autonomy they use in the platform, although the insignificant proportion is experiencing occasional difficulty. Information clearly improvising the valid, with some students reporting confusion. Content comprehend the present grid change, while mobile device usage show the very safety. Overlay the platform exhibiting accessibility the barrier for the ranking attention. Autonomy and clear result. Levied autonomy. Fixing full autonomy. Participating, navigating, or the use platform which need help. Foreign internet support. Requiring support help to complete certain tasks. 10. Constant assistance. Needs continue support the platform activities. Clearing information. 65 very clear information was were amazing to understand. 25 some was confused. Some instructions were not hardly clear. Item not clear. Much confusion, no on steps to follow. Improving proposal. Virtual single language interpreter. For case instruction on institutional platform. Usability button. Along kit activation on subtitle on visual guide. Customizer subtitle in audio material with tape and color option. Send learning ground recursor for the recording and academic progress like environment on console. In mobile optimization, improve visual and navigation mobile device. Limit of the student. Limit of the student, the statistical generalization, the trunk factor, profile heterogeneity. Lights of the outer matrix, light usable metric, the error of status utilities. Lights of object metric. Specific content resultant circle the UTM and the platform SHA the virtual system is limited frequently. Interpreter depends, presencia the interpret limit, communication autonomy and may affect natural response. Language invariant, some interpretation, high difficulty in understand, reading Spanish, and sing language. Conclusion, identify barriers. Students with hearing disabled they face significant barriers on UTM platform. Content comprehension, navigation clarity, and lack of visual communication audio. Naturally or accessibly. Accessibly requires coherence between interfacing, institutional covering, and participation of users with speech needs. I know the technical activation. With component processing, accessible visual assert, musical gain, and sign language content interface resins, solo based or at technology or the user-centric design. Requiring of for implement, sustain institutional commitment, training of technical team, and continue evaluation with participation of a student with hearing disabled. Recommendation for future requests. Expand the support core, including multiple Equatorian and Latin American universities, incorporating perspectives from its faculty, administration, the senior on technical team,
Hello.
metric A, complete ranking laws with usable
Excuse
metric.
me. Sorry for interrupting. This is just a gentle reminder that 1 minute is left for presentation.
Repeat.
This is
Can
just
you
a
repeat?
yes, 1 minute is left for your presentation. So can you please conclude?
Okay. Thank you.
I think you misunderstood me. 1 minute is left for your presentation.
In conclusion, this student holiday was already some student with hearing disabled can use an institutional platform independent. There are still important accessibility barriers that affect their experience, the barrier relay navigation, content unit state, or the language support. Thank you.
Session chairs, do you have any questions?
Okay.
I have one comment, not the question. The sample size and the population size of 70 and 10 respectively is very small to conclude anything. So that is the comment that I would like to give to you.
Okay. Can you give me a moment, please? Because I hand the translator here for me. Repeat, please.
The sample size of 10 and the population size of 70 is too small to actually concretely conclude anything. So you should focus on increasing the sample size when you do such an research about inclusiveness.
Okay.
Okay, Steve, that's my suggestion. Okay.
Thank you, Stephen.
Thank you for your observation. It's true that population size is relatively small since it consists of 88 students with hearing disabilities registered at university, and from this group, example of 10 participants was selected intentionally. However, this study has exploratory approach, so the objective was not to generalize the results but to identify usability patterns and accessibility barriers. For future research, increasing the sample size and including participants from other institutions will definitely strengthen the validity and generalization of the findings.
Yeah, thank you.
Thank you, Stephen, for the presentation. And with that, we have come to the end of this session. I sincerely thank all the authors for the excellent presentations and valuable contributions. I also extend my gratitude to all participants for being a part of this conference. I hope this session has been informative and enriching. On behalf of the organizing team, thank you for your continued support for ICTIS over the years. We look forward to welcoming you again at the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication process will be completed within 7 to 8 months. Kindly extend your cooperation to the ICTIS 2026 team during this period. I would also like to thank our session chairs, Dr. Preeti and Dr. Rana, for effectively sharing this session. And as a token of appreciation, we present this. Session chairs, would you please like to have a few minutes? Okay, I request everyone to turn on the camera so that we can have a quick snapshot of the session. Thank you everyone for joining. Have a great day.